In this video, I'm going to talk about system of linear equations in two variables. These are examples of system of linear equations in two variables, x and y. Sometimes it's represented by the brackets here, meaning it's a simultaneous equation or it's a system of equations. And each equation here is in general form where the constant is on the right side, and in this type of system each equation is in slope intercept form. Sometimes they're mixed of the two. Now here we have the graph of these two linear equations, where the blue one is the graph of the first equation here, and the red one is the graph of the second equation here. In this particular system, we have a solution. The solution is the intersection of the line. So here, the solution, or we write it, solution set is a set containing point where your x is 0 and the y is 3. So there's only one solution in this system. Now, let's go to the types of systems of equation. Now, here, it's similar to the previous one. We have one intersection or one solution. And the solution set for this one is the set of points. Your x is -1 and the y is 1. This type of system is called consistent system. Or consistent and independent system. This one, notice that they don't have intersection, so the solution set of this system is empty since the lines are parallel, or a null set. This type of system is called inconsistent. The third one, we have the coincidental lines. So all the points they shared to each other. So the solution set of this one is infinitely many, which is all the points of the line. That is, the points x, y that satisfies any of these lines. So we can select only one of these. I will select this equation here. You can also select the second one. It's up to you. Cos 3. So that's the solution. And this system is called consistent and dependent. So it is consistent and dependent, or just simply dependent system. Now notice here, if you look at the system equations, take the ratio of the coefficients. We'll have the ratio of the coefficient of our x, that's -2, and the coefficient of our second one, which is -1. Now, you can say that the system is inconsistent if the ratio of the coefficients of your y and the coefficient of your x are different. Now, let's look at it here. This one here is +1 over -1. So, on the left side, that's equal to 2. And the right side is equal to -1, so they don't have the same ratio. That means it's inconsistent. Consistent and independent. Now if you look at here, we have the ratio of the coefficient of our x is -2 over -2. That's actually equal to 1. And the ratio coefficient of our y, that is 1 over 1. And that's equal to 1. And they're equal. But you have to consider the constants as well. The ratio of the constants, which is 3 over -2. So here they're equal here and not equal here. That means it's inconsistent. And pretty obvious actually, because here they have the same slope. So if you write this in a slope-intercept form, you have y equals 2x plus 3. Here, y equals 2x minus 2. So they have the same slope, but they only differ in the y-intercept, or where the point they intersect at the y-axis. So notice here the y-intercept is 3. So this is the y-intercept of the blue line. And here the red line, the y-intercept is -2. So that shows that they are parallel. And the next one, if you compare the ratio of their coefficients, this is -2 over -6, and the coefficients of our y is 1 and 2. Now let's look at here. This ratio is 1 over 3, right? And this one is 1/2, and this one is 1/2. Okay, I'll change a little bit here. I think we made a mistake here. This is 4. Sorry, that's okay. We'll change that to 4. There we go. Okay, it's 1/2 as well. So they have the same coefficients. The reason is because they're just the same line. If you multiply 2 to both sides of this equation, it will result to a red equation here. Okay, that means multiply that by 2, you will have -4x plus 2y equals 6, which is exactly the same as the equation here. That's why they coincide. Alright, now let's move to this system of equations here. Now here let's focus on how to solve a system of equations using the elimination method or substitution method. Okay, the first thing you do is to eliminate one of the variables here. So if you decide to eliminate y, you can only multiply 3 here. Okay, they're already opposite signs, so it will easily eliminate it. Now let's change this once. This equation now is -18x plus 3y equals 42. Here, just copy this one, which is 2x minus 3y equals 6. And then let's add the two equations. This is already 0, and this one is -16x. This is equal to 48x. If you divide -16 both sides, so that we can isolate our x, so cancel out, x equals negative, that is 3. That's our x, but we're not done yet. We can substitute our x to any of the equation here. Suppose this is your equation 1 or equation 2, you can call it. So we substitute x equals -3 to equation. You select equation 1 perhaps. Okay, you can use equation 2 as well. So we have 2 times -3 minus 3 times y plus 6. Now here that's -6 minus 3y plus 6. You can move this to the right side, so that will become plus 6. So -3y plus 12. Divide -3 both sides. This will cancel out, and y equals -4. Okay. Now just for curiosity, what if you decided to eliminate the x first? Okay. We decided to eliminate the x first. Do we get the same result? Okay, now let's try it. 2x minus 3x, 3y plus 6, -6x plus y plus 14. Now here we multiply 3. That will become positive x. Okay, this is now 6x. 3 times -3, that's -9y. 3 times 6, that gives you 18. And let's copy that one. That's 6x plus y plus 14. We add the equations. This is -8y here. And this is equal to 32. Let's continue. So we divide -8 both sides. So y equals 32 over -8. Y equals to -4. So we get the value of our y the same as that. Now we can substitute y equals -4 to any of the equations. So suppose let's use the equation 1. So you have 2x minus 3 times -4 plus 6. Just copy this one and then multiply this. That's plus 12. 6. So 2x, move the 12 there. That becomes minus 12. So 2x equals -6, and we divide 2 both sides. That gives us x equals -3. So we arrive on the same answer. So the solution set this equation, system equations, is okay. Our x is -3 and y is -4. You can also check your answer by plugging our x and y value to the system. But we will do that to the next equation here. Now here, let's decide which variable to eliminate. I think it's easy to eliminate the x. Okay, I will eliminate the x by multiplying 3 both sides of this equation. So this now becomes -15x plus, distribute the 3 here, becomes 3y. 3 times 4, that's 12. And let's copy this equation here. And add them. This is now 0. This is -3y. Gives us 0. So divide -3. -3. That gives us y equals 0. Next, let's solve for our x. Let's use this equation 1 here. Let's substitute. Okay, substitute y equals 0. to equation 1. So we have 5x plus change your y to 0 plus 4. And then we have minus 5x plus 4. We'll divide negative 5 both sides. So for x, cancel out, x equals negative 4 over 5. Now, if you're unsure about your answer, we can use the checking. Okay, let's check first if this is really true, where possible solution is negative 4 over 5 and y is 0. Let's plug it into the equation here. Our x is, okay, for equation 1, x is negative 4 over 5 plus our y is 0. Okay, let's continue. Let's simplify this. That's 20 over 5 plus 0, which is just equal to this one. 20 divided by 5 give us 4, which is correct. Got a 4 there. And you have to try to the second equation as well, not only one equation. So 15 times negative 4 over 5 minus 6, y is 0. And we can reduce that. It's equal to 3. 3 times negative 4 is negative 12. That's 0. And negative 12 minus 0 is just negative 12, which is equal to the right-hand side of the equation. Therefore, we're very confident that the solution set is the set containing x, which is negative 4 over 5, and the y is 0. Let's move to the third equation here. Let's decide which variable to eliminate first. Suppose you decided to eliminate the x, and the coefficient of our x is 8 and this one is 12. Oh, you need to get the LCM, okay, least common multiple of the two. If you don't know how to find the least common multiple, then you can use this repeated division method. You write 8 and 12, so you find the number that can divide the two of them, which is 4. Okay, so 8 divided by 4 is 2, 12 divided by 4 is 3. Is there any more number can divide them? No, so that means you just simply add all of this. So 4 times 2 times 3. So the LCM is, that's 8, 24. Okay, so the LCM is 24. That means we'll multiply, since that's 8 there, that's 4 times 2, we multiply 3 to make it 24. So 3. And this is 12 here. That's 4 times 3. We multiply 2 to make it 24. And since they have the same sign, so we just make the other sign negative, so that we will have opposite signs. Here, let's distribute first, multiplying factor 3 here. 3 times 8 gives us 24x. 3 times negative 6, negative 18y. 3 times 4 gives us 12. This one is also negative 24. That's negative 16. Y. That's negative 40. And then we add them. This one is already 0. This is negative 34. Negative 34y equals, and this is equal to, negative 28. Negative 28. And then let's divide that by negative 34. Okay, both sides gives us y equals 28 over 34. Now we can simplify this one by dividing by 2, gives us 14, gives us 17. Okay, we got 14 over 17 for our y. And let's use one of the equation here, equation 1, equation 2, to substitute the value of y to get our x. I will use equation 1. So I will substitute my y equals 14 over 17 to equation 1. So I have now 8x minus 6 times 14 over 17 equals 4. 8x minus, what's this equal to? That's 84 over 17 plus 4. Transpose that to this side. So that's plus 84 over 17. We have 8x here. Let's multiply that. That's 40, 68 plus 84 over 17. And we can divide 8 or multiply 1 over 8. Okay, both sides. So 8 will cancel out, gives us 8. 68 plus 184, that is 152. 17 times 8, that is 80, plus 56, 136. Okay, so this is the value of our x, and therefore our solution set. Let's move to the next one over here. Here it seems easy to eliminate the y, so just simply eliminate them directly. Okay, then I will give this for you as your exercise. I will do this one instead. The x is already given, so you just simply substitute it. Substitute your x equals -2 to our equation 2. 4 times -2 plus 3y equals -2. That is -8 plus 3y plus -2. Transpose that here, becomes plus 8. So this is now 3y. Okay, this is -2 here. Gives us 6 by 3. So y equals 2. And the solution set, meaning our x is -2 and y is 2. If you want to see the graph of this equation, okay, it's like this. The graph over x is x is -2. That's 1, 2. X is -2. That means our x is -2 for all value of y. So it's it's a vertical line that cross -2. Sorry, that's -2. Okay, and this one you can look at it using the graphing calculator. Okay, that's x equals, yeah, x equals -2, and 4x plus 3y equals -2. Okay, so this is the solution, which is x is -2 and y is 2.